So Clay Flannigan is the manager of Robotics and Automation Engineering section at SWRI Research Institute. His talk's going to be on industrial robotics, recent advancements in sensing, software, mobility, and safety that are driving innovation. Clay supervises a group at SWRI Research Institute that focuses on transitioning basic research to real-world automation solutions for industrial systems. His areas of expertise include sensing and perception, machine learning, robotic manipulation, and mobility. Clay is involved in programs that include self-driving vehicles, some of the largest robots in the world, and robotic systems that are able to adapt to dynamic environments. He is a Master of Science in Mechanical Engineering and over 15 years' experience in developing automated solutions. One of Clay's group's primary focuses is on advanced technologies for industrial robotics and automation. His talk will be centered around recent advancements in this area as they might relate to drilling technologies. Clay, all yours.
All right. Thank you, John. So as John mentioned, I'm a manager of robotics and automation at SWRI Research Institute. For those of you who aren't familiar with the Institute, we are a nonprofit applied research and development organization located in San Antonio, Texas on 1,500 acres. We have about 3,000 staff, do about $500 million worth of research and development every year. And we focus on providing contract research and development, engineering, and testing services for a wide range of industries and organizations, both government and commercial. We're a pretty diverse organization, have 11 different technical divisions addressing many different types of technical needs. And we do robotics in a lot of those areas. So as a little bit of background, I'd like to just give you sort of a sampling of some of the work that we've accomplished in the last few years. My group developed some very large robotic systems. This is a picture of one that we just deployed for Hill Air Force Base. It's a very large dual robot system used to remove coatings from aerospace applications, in this case F-22 aircraft. Some of the largest robotic systems in the world, all custom designed by us. So we do all the controls, all the mechanics, all the software for them, and then support them in the field. This was an interesting program, a program we were involved with. It's NASA funded, and the goal of this program was to search for life in underwater environments. So the aspirations here on this program were towards development of technologies that could be used to explore one of the moons of Jupiter, which is thought to have an ice shell with water underneath. And just as on Earth, anywhere where there's water, there's life, the planetary scientists are very interested in trying to explore that environment. So this program was involved in developing technologies to autonomously search those underwater environments. Obviously, we did this here on Earth. But we did explore some previously unexplored caves in Mexico, mapped them out, and actually found some new life forms. We also do a lot of unmanned ground vehicle research at SWRI Research. This is a picture of our MARTI vehicle. MARTI stands for Mobile Autonomous Robotics Technology Initiative. It's a multi-year, multi-million-dollar program focused on developing technologies for unmanned systems. So the DoD and the military have a lot of applications in this area for things like logistics and resupply. And there's commercial applications, too, for things like active safety systems and communication between vehicles, communications with infrastructure and roadways. So a very diverse group of robotics programs kind of mirrors the diversity at the Institute. So my particular group does a lot of work in industrial and manufacturing environments. And this picture at the top here is kind of what everybody thinks of when you think of industrial robots. It's a paint shop from an automotive line and has been one of the major drivers in industrial robotics for decades now. It was really in the 80s and the 90s that was the heyday of, in terms of growth of the industrial robotics industry. But since then, a lot of things have sort of stagnated there. There's been incremental improvements, but we haven't seen real disruptive change in the industrial robotics world since that time. So today I'm going to talk about 4 different areas where there is some really exciting changes going on that I think are going to make some of these sort of future visions of Rosie the robot a possibility in the near future. So specifically, I'm going to talk a little bit about sensors, software systems, mobility, and then safety and regulations, and how those are impacting the industrial and commercial robotics industry. So first up, sensing systems. So traditionally, when you have an industrial robotics system, you need some form of sensor that is used to provide guidance for that robot. So in this picture here, you can see the robot is picking up muffins from one conveyor, putting them into a case in another. Very classic application of industrial robotics. That's typically solved by a 2D vision solution or machine vision, computer vision. So you've got a camera installed on the system looking at the muffins coming down the conveyor. And as long as the muffins are well behaved, i.e. the top side is up and the bottom side is down, this solution works pretty well. It's a planar solution though, right? It's a 2 degree of freedom problem. You really only have to figure out where those muffins are in an XY sense. And that was kind of the state of things through really the late 80s through the 90s and even up until now. But when you start thinking about trying to do more interesting things in natural or complex environments, you really need to start thinking in a 3D sense. So roboticists have been exploring 3D sensing as a field for a long time, and there's a number of approaches to accomplish that from a hardware perspective. So on the top there you can see a picture of a stereo vision camera. It's basically got 2 cameras, just like human eyes provide a sense of depth for us. You can do the same thing for a robot by using 2 cameras and correlating the 2 images. And that gives you some sense of depth or 3D vision. Here in the middle is a picture of a structured light solution. So that's very similar to stereo vision, where except that you only have 1 camera and the other camera is replaced with some form of projector where you display a known structured light. In this case, it's a laser line, which you can kind of maybe barely see across there. And by extracting the location of that line and the view of the camera, you can, again, extract depth information. And then down here on the bottom is a time-of-flight sensor. This one is made by a company called Mesa Imaging. And essentially what these sensors do is they send out a pulse of light and measure the phase difference between the pulse going out and the return signal. And in doing so, you can effectively measure the time of flight or how long it takes for that light to return to the sensor. So all of these approaches have some problems with them, and roboticists have been struggling with them for a long time. So for example, with stereo vision, if you don't have much texture in your image, like for example, if you were looking at a blank wall, you wouldn't get any information back because there's no way to correlate those textureless views. And time-of-flight sensors sometimes have problems on very shiny surfaces. You don't get a good return from them. In addition, most of these solutions are very expensive, tens of thousands of dollars, which makes them prohibitive for most manufacturing applications. So that was kind of the state of affairs for a number of years, really a decade or more, and then this happened. So most of you probably recognize that. It's Microsoft Xbox Connect. So Microsoft and a company called PrimeSense out of Israel collaborated or partnered to develop this device. And essentially it's a structured light sensor, similar to the other one that I showed you, except that there's a lot of engineering that went behind this thing to make it very high performance. So Microsoft had the idea of building this sensor and making it very cheap, and their goal behind it is to track human motion. But it's still a 3D sensing problem, just as roboticists have been trying to solve for a long time. Interestingly, though, Microsoft didn't really see that initially. They released this thing to the world as a game controller, and immediately roboticists jumped all over it, started hacking it, reverse engineered it, and Microsoft said, no, please stop. We're going to sue you.